Hello everyone. This is my first open source complete project that I want to share with you and create together from scratch. I would like to create a small adjustable power supply with a USB-C input and no external panel. It should be controllable via a web UI and capable of current monitoring. I have chosen the MP4245 for DC-DC conversion. Let's review the datasheet. As you can see, it's quite small and requires only a few external components. It can handle up to 60 watt, although we may not require that much power. It operates well with a 5-volt input, and the output voltage is adjustable from 1 volt to 23 volt. Here are the input voltage, I2C pins for configuration, and the output pin. I recommended a quick look at the datasheet. Here, I want to show you all the registers inside the chip. As you can see, we can read a wealth of information, including input voltage, output current, and temperature. Additionally, we can set parameters such as output voltage, current limit, and more. Now I would like to introduce the microcontroller I've selected, the ESP32C6 mini module, which supports Wi-Fi 6. I believe it's an excellent choice for this project due to its compact size and powerful capabilities. It has 512 kilobytes of RAM, which I believe is sufficient for this project. Furthermore, it supports USB programming for convenient development. For hardware design, we need to carefully review the datasheet, paying close attention to the usage of pins, such as strapping pins and boot pins. In this project, I am using EZDA, a free and powerful CAD tool provided by spply. As you can see, it features both an online design editor and offers offline downloads compatible with all major operating systems. I have downloaded this version for my use. There is a slight difference between the standard and professional versions. Aside from the spply simulator, the professional version offers a significantly wider range of features. I installed it earlier and am now running it. I am now creating a new project and assigning a folder for it. As a first step, I'd like to draw an overview of the project. As mentioned earlier, this is my first time using this software, but I'm finding it quite intuitive and easy to navigate. I apologize for the omission earlier. We will also require a current measurement op-amp to accurately measure low current levels at the load. I chose the INA 210 series. There are several options with different gains, and we need to decide which one is best suited for our circuit. We can select from gains ranging from 50 to 1000. This is an overview of my new project. I'm eager to hear your ideas and suggestions. Feel free to leave a comment below. I'll be starting the PCB design very soon, and I'm excited to share the progress.